Meteors and meteorites are fascinating phenomena that have intrigued humanity for millennia. These cosmic events have diverse origins and characteristics, and studying them helps us better understand the history and nature of our solar system and the universe we live in. A meteor is a luminous phenomenon that occurs when a celestial object, usually a fragment of space rock known as a meteoroid, enters Earth's atmosphere at extremely high speed. When the meteoroid comes into contact with the atmospheric layers, it creates friction with the air, generating intense heat and causing the object to ignite and shine brightly. This characteristic glow is what we see as a meteor, popularly known as a shooting star. Meteors are often observed during events such as meteor showers, which occur when Earth crosses the orbit of a comet or encounters a region of space where there is a higher concentration of meteoroids. During a meteor shower, it is possible to observe multiple meteors per hour, creating an impressive spectacle in the night sky. However, not all meteors that enter Earth's atmosphere completely disintegrate. Some meteors survive the heat of entry into the atmosphere and reach the planet's surface. These rocky fragments that reach Earth are called meteorites. Meteorites vary in size, shape, and composition, and their analysis can provide valuable information about the chemical and physical composition of the early solar system. Additionally, the impacts of large meteorites with Earth have played a significant role in the planet's history, causing mass extinctions, forming impressive craters, and shaping the terrestrial environment over billions of years. One of the most well-known events involving meteorites is the Chicxulub meteorite impact, which struck the Yucatan Peninsula in Mexico about 66 million years ago. It is believed that this cataclysmic impact was one of the main factors responsible for the extinction of the dinosaurs and many other forms of life on Earth. In addition to their historical and scientific impacts, meteorites also have great cultural and commercial value. Many collectors and museums seek to acquire meteorites for study and exhibition, and the meteorite trade is a growing industry worldwide. In summary, meteors and meteorites are celestial phenomena that play an important role in Earth's history and science. They connect us with the vast and mysterious cosmos, reminding us of our position as inhabitants of a small planet in a vast and ever-evolving universe. And what is humanity's concern about these gigantic ones that pass over our heads every day? The skies, vast and infinite, hide in their starry mantle a cosmic spectacle in constant motion. Among the wonders that transit through the firmament, meteors and meteorites awaken both fascination and unease. Humanity's concern regarding these celestial bodies is multifaceted, reflecting both scientific potential and fears of catastrophic impacts. On a scientific level, meteors and meteorites offer a unique window into understanding the formation and evolution of the solar system. Each fragment that burns upon entering Earth's atmosphere carries clues about the processes that have shaped our cosmos over billions of years. However, beyond scientific interest, there is also concern about the risks associated with these celestial bodies. Although most meteors are harmless and completely disintegrate in the atmosphere, there is always the possibility that a large meteorite could escape incineration and strike Earth's surface with devastating consequences. Historical events, such as the Chicxulub meteorite impact, which has been associated with the mass extinction of the dinosaurs, serve as dark reminders of the potential impact of these celestial bodies on life on Earth. The impact of a large meteorite could trigger tsunamis, widespread forest fires, drastic climate changes, and even a possible mass extinction. For this reason, humanity's concern regarding meteors and meteorites includes efforts to detect, track, and understand these celestial bodies, as well as to develop strategies to mitigate the risks of potential impacts. Space and terrestrial observatories constantly monitor the sky for objects near Earth that could pose a threat. Additionally, space agencies and international organizations collaborate on planetary defense projects, developing technologies that could be used to deflect or destroy a meteorite on a collision course with Earth. These efforts aim to protect our planet and ensure the safety and survival of life here. Therefore, humanity's concern regarding meteors and meteorites is a mixture of scientific curiosity, respect for the unknown, and awareness of the potential dangers these celestial bodies represent. As we continue to explore the universe and unravel its mysteries, we must also remain vigilant and prepared to face the challenges it presents. Imagine if a meteor were to collide with Earth. Have you ever considered the catastrophe that would occur? The mere contemplation of such a scenario evokes a mixture of fascination and terror, for the consequences of such a cosmic impact would be devastating and potentially catastrophic for life on our planet. The collision of a meteor with Earth is an event that raises deep concerns and has long been the subject of scientific speculation, literature, and cinema. Although scientists are constantly monitoring space for objects near Earth that may pose an impact threat, the possibility of a large meteor striking our planet remains a real and worrisome threat. The consequences of a meteor impact would be devastating in several aspects. First, the energy released by the collision would be equivalent to several nuclear bombs, causing a cataclysmic explosion capable of completely destroying large areas around the impact site. Additionally, the impact would generate intense heat and a shockwave that would propagate through the atmosphere, causing widespread fires and destruction on a large scale. The crater formed by the impact itself would be enormous, leaving a visible scar on the Earth's surface for thousands, or even millions, of years. Depending on the size and speed of the meteor, the crater could be hundreds of kilometers in diameter and be deep enough to permanently alter the topography of the affected region. In addition to the immediate damage caused by the direct impact, a large meteor would also have devastating secondary effects. Dust and debris ejected into the atmosphere would block sunlight, causing a sudden global cooling known as a nuclear winter. This would result in a drastic drop in temperatures, affecting the climate and agriculture worldwide. Food shortages and resulting social unrest could lead to a global humanitarian crisis of epic proportions. Furthermore, a meteor impact could generate gigantic tsunamis if it occurred in the ocean, flooding coastal areas and causing even more destruction and loss of life. The shock waves resulting from the impact also had the potential to trigger earthquakes and volcanic eruptions in locations far from the initial impact point, further increasing devastation on a global scale. In summary, the possibility of a meteor striking Earth is a real and worrying threat that requires attention and adequate preparation from humanity. Although it is impossible to accurately predict when or where a cosmic impact will occur, ongoing efforts to monitor space and develop planetary defense strategies are essential to protect our civilization and ensure the survival of life on Earth.